Hi everyone. So today I'm gonna demonstrate a tool called PyCaret. So this is an open source low-code machine learning library which we have in Python, which makes data scientist life very easy. So it is an auto ML low-code tool which can be used to do various tasks. It has inbuilt libraries such as scikit-learn and XGBoost inbuilt in it. I have created few notebooks, some of which I have used dataset from the PyCaret itself. So we have already these list of datasets in the PyCaret. So first one is the binary classification, in which I've used this hard dataset. It is predicting the death based on various parameters. So we are setting up the model here using PyCaret with just one line here, and then we are comparing the models. So just by doing compare model, it is in background comparing different type of models here and giving us the best model based on different metrics. And then it has evaluate. After evaluating the model, we have different. These kind of charts are coming up here. So we can see this is the pipeline here. The raw data is coming. So best model here is Calboost, and we can see the raw data, and then it is simple imputer is there, and then we have this model. So we can see different type of charts like area under the curve, and then we have confusion matrix here, and it is just happening using just one line. Then we can also predict the model on our created data and check the prediction score, and we can save the model and load the model again. So this is saving in the memory, saving in the disk, I think, and then it is loading it here, and we can see the pipeline of the model. We can also fine tune the metrics here. We can add custom metrics. We have added this here, and then compare it on the so we can compare it on the custom metrics, R metrics, and then we can also do when we have created here a decision tree model, and then we can tune this model here and check the accuracy. So this is the tune model. This is tuner, which is again the decision tree classifier here, and this is the accuracy. This is the matrix. You can assemble the model using like different methods like bagging and boosting. We have also a way to deploy the model directly using using Gradio. So just by create app, and we are passing a model here. We can pass different models as well, and it has created this amazing UI where we can. This is opened here. So where we can just put the values, and it is showing what is the prediction score directly here. Okay, next we have is a multi-class classification. I have used a data which is already present in the PyCaret, which is poker dataset. It is which this is classifying it is classifying based on this class row here. We have here what we have done is we have set up the model, compared different models. Calboost classifier is coming up the best one, and then we can check like the evaluation. Again, we have these different parameters, and then we can predict the model. Yeah. Next, we have is the regression model, where I have used Candy dataset from Kaggle, and it is predicting the win rate, which is like the customer satisfaction rate based on different parameters. And initially we have set up, then we have compared the model. We get evaluation of the best model, different charts and all. Here is the LGBM regressor. And then we can also predict the we can predict the model on our own data set and check the accuracy. So here we can what this I've done is we can also do one thing where we can have three models based on So this is comparing the model based on a mean absolute error, and then the best three models is blended here, and we can check the leaderboard as well of different models based on metrics like the precision and mean absolute error metrics. Yeah. And then this AutoML is like just by running this, it automatically does many operations behind and give us the best model here. Again, I've deployed this model. I think it has disappeared because the cell is the notebook is inactive. But we can deploy it just by one click. I have another notebook here, which is clustering. So for this, I have used Pokemon Go dataset from Kaggle, and this is what we are doing here is like, so I've done some data manipulation task, and then we have the data setting up again, and then creating the k-means model. The k-means model will create some clusters of each entry. It will classify these entries properly. Then we have this amazing table where we can see the classifications. We have different charts here, and then we can see the evaluation of the model, k-means model, and yeah, we can save and load the model in the memory. So this I've kept it here to show that we can also deploy the model on AWS using PyCaret directly. Next we have is association rule mining. So PyCaret 3 is not the association function in PyCaret is depreciated. So I have used some other library. I tried this previous version, but it was not supported for the OS environment, it seems. So quickly, I've just used another ML library called ML Extend, which is using this guitar a priori analysis, and we are using this to just have an association rule, uh, identifying the association rule here. So this is what are the results here, and then next we have is anomaly detection. For this, I've used Kaggle dataset, and it is using this participants. Sorry, it is using this data set where there are different features, and it's just giving if it is if there is anomaly or not. It has so I've done few data manipulation here, and then we have set up, uh, and then we are creating isolation for the model, and so this is the model which was created. It has plotted this amazing graph where it has shown us like this is the 3D model, 3D graph. We after evaluation we also have this different charts here. We can have different parameters of ours, like the contamination here is 0.1. We can change this and check. So we can have different type of experiments, and we can save those experiments and load them again. Next we have is time series forecasting, univariate univariate without external variable. So for this I've used airline dataset. Uh, so this is setting up again, and then we are comparing different models. So this is the so for this we have got STL forecaster. And what this is doing is just predicting based on the previous data set. We can also see the statistics of the model over here. Next, we have is time series forecast univariate with exogenous variable. Uh, we have this. Yeah, for this I have used air quality dataset, and yeah, so these are the results here. We have these charts which are coming up. Next, I have also created another file where I've just created a demo where I have just deployed the model, created an application using Gradio again, and this was the result over here. That's it. So I have attached this notebooks GitHub link in the description as well. All right. Thank you so much.